Hi, and this is a quick overview of the postmodern data stack project and repository. What we're trying to do in a nutshell is basically have an end-to-end pipeline that goes from raw data, which is actually real world data from anonymized shopping session, to an endpoint serving prediction for a recommender system. And we're gonna go all the way end to end from data to prediction, showing how you can do that basically without any explicit infrastructure work and in a totally scalable and replicable way. In particular, we're going to show you how to join the DataOps component of a pipeline, Snowflake and dbt, with the MLOps component of a pipeline. So model training, experiment tracking, testing, and of course deploying. The underlying technology we're gonna use is Metaflow, which is basically in charge of orchestrating all these logical steps. It's basically a DAG from start to finish. So there's a bit of setup to do, and you can check which prerequisite there are to run this repo. We're gonna just assume that you have successfully created a Snowflake account, it's free, and then you were able to upload the data, which again is open source and free, and there's a script to do it in the repository to Snowflake. Okay, and you can kind of think of this flow as being, of course, this is the full picture, but you can think of this flow as being somehow composable, as you can increase the complexity of the tool you want to use from the bare minimum, let's say Snowflake, dbt, and Metaflow basically, and then you can add or remove components as you see fit, and then you get more comfortable with the technology. The typical project is just structured as a standard Metaflow project with a flow, which we're gonna see, which is where all these steps are declared and all the main logic is explained. It's in pure in Python. A dbt folder, which you can guess, contains just your standard dbt project. Is the usual things that you all know and love. So, for example, this is the query that goes from the raw dataset that again we assume you have in your Snowflake to somehow a better representation of the data. And this is a query that instead prepares the event to be ready for training downstream. And then what you have here in the flow file is a typical, you see here, is a typical Metaflow class. For those of you who are not familiar with it. And it's just basically a list of steps in Python that are joined together by this next syntax here, which define a DAG of function going from start to all the way to the end. All of this is like less than 500 lines of code. And again, many of them are redundant for pedagogical reason, gets you from zero to actually a running endpoint in the cloud. When everything is installed, you can run it just as a standard Metaflow flow. So when you run it, in this case, we're gonna run it without the use of AWS Patch. It's all configurable, and the repo goes in great length to explain you how to set up in a way in which you can actually leverage cloud GPUs if you want to. But now we're just gonna run like a local version. And what we're gonna do is that we're gonna spin up this pipeline, and the system is gonna go through all the phases from like collecting from running dbt on raw data, so it's going to run a dbt job, to collecting the features after the dbt run, to train a machine learning model for recommendation. In this case, is a simple STM using Recklist, our own open source library for recommendation testing, to test it, and then finally deploying using SageMaker. As you can see here, Metaflow is running a dbt run command. So in particular, is running the content of the dbt models that we have locally. There's an option that you can enable if you want to use dbt cloud, which is going to use dbt cloud APIs to run a dbt cloud job instead of a local one. So this stack is perfectly compatible with either dbt core or dbt cloud, and you can just swap in and out one or the other depending on your preferences. Now we started training our model. And we're using an experiment tracker platform. In this case, it's Comet, to track what's happening in our training session. So when you run this, of course, different times, with different data or different parameters, or whatever you want to do, you're gonna get like a general visual um, um, comparison of all the different models and different parameters you do. And in real time, if you want, you can actually see what's going to happen with the current model architecture and data that they're having. And as you can see here, we're going to have all of this being updated in real time as the model is training. Now it's a very simple model, and again, it's trained locally, so it's going to take a while. Um, but the cool thing about the postmodern data stack is that it's basically infinitely scalable, as it's already set up in a way that by basically just changing one parameter without any code changes, you can ship this very same TensorFlow code to run on one or more GPUs if you want in the cloud, and get like an incredible speed up um, because of that. After the model is trained, we add an important component of any realistic data and ML pipeline, which is a testing step. In this testing step, we're going to leverage our open source library. It's called Recklist, and we prepare just a stub of what a suite of tests for this particular use case would look like. The intent of this step is not to show you like a full-fledged rec list and behavioral testing suite on these particular use cases, and that's kind of like a topic for our discussion. But it's already to give you, in this very modular setup, an idea of how that behavioral testing could be seamlessly integrated in your flow, and you can basically expand on it as much as you want by keeping the rest of it intact. This is kind of a design principle of our postmodern data stack, as in all the components to build like actually a real world production pipeline are there, and some of them are just there as a small draft. And you're very welcome, of course, to expand on that and add functionalities. But you can do that in a way that kind of doesn't really interfere with everything else. So even if there's one tool that you prefer to some of the tools that we propose, again, there's some improvement you want to make on the modeling side and so on and so forth. At the end of the day, you should be able to kind of swap in and out the pieces of the puzzle without really interfere with anything else. The last step, of course, after we run our test, is to deploy. You can disable deployment if you don't wish to do so. But if you want to see how this model actually can be performing real-time inference based on all the data that you prepare with DBT and the model that you train on with Metaflow on your local machine or AWS, we're going to use SageMaker in this case to just again pure Python to spin up an endpoint that actually will run prediction for us. If you look into your SageMaker console, at this point, you will see that a new endpoint for next event prediction (NEP) is being created. You see here the status is creating, and this step, you're gonna wait until the model is created, and it's gonna run some testing prediction, and it's gonna also delete the endpoint because we don't want to spend unnecessary money since it's a tutorial. Of course, in a real use case, you wouldn't delete the endpoint after you actually deploy it. But this does to show you, again, how a flow will work end to end without you having to explicitly um, deploy any infrastructure or use anything that is not basically SQL or Python. Once the endpoint is up and running, you can check here if you refresh your SageMaker page. Now it's been already deleted. Perfect. So when the endpoint is up and running, what's going to happen is that we're going to run one prediction just to make sure the endpoint is working. And then you can see here, we're going to delete the endpoint. In fact, if you refresh here, as we saw, there's no more endpoint. So the endpoint is being created, has been up for like 30 seconds, just to make sure that we can run some prediction out of it and we can print the result. And then, of course, it's going to be deleted to, again, save resources, since this is just like a stub. At the end, we run basically, so once the setup is done, very, very few lines of Python and a bunch of SQL will allow you to run what actually amounts to be like an almost production ready flow um, from start to finish. And again, it will allow you to run without knowing any detail about infrastructure or without depending on any data engineering team of the about person. As a cherry on top, if you want to see the results of your test, again, remember we run Recklist as our testing framework for recommendation, and we just show, again, it's a stub, but it's infinitely improvable. We show how to combine the output of Recklist, so the test that we actually run, with a very nice functionality of Metaflow, which are the model cards. So if you decorate your um, Metaflow step in a proper way, you can actually get for free this, again, like a very simple card. You can get for free an artifact that has been saved and stored and versioned like any other Metaflow artifacts that kind of describe what happens in that specific run, and you can fill it with custom information. So in this case, what we did is we'll take the Metaflow card functionality as basically scaffolding for our information, and we inject the results of our recommendation test. In this case, is a simple iterated 10 test. But of course, again, the more you improve your rec list, the more you can think of improving this card. And this will basically contain um, documentation that is automatically produced and versioned and stored for you. So every time you run this flow, even in production, you're going to get a copy of this information that can be shared not just inside your technical team, but outside the technical team, like your PMs or other stakeholders. We hope you enjoy the journey from raw data to transformation to training to testing and finally to deploying. And of course, we remain at your disposal should you have any question on how to best run this postmodern data stack. Ciao.